In this video, I'm going to talk about how to build a highly scalable e-commerce website. Now, this is a very common topic when it comes to testing your system design skills. So in this video, I'm going to cover everything from, the infrastructure side that is going to be needed in constructing a highly scalable e-commerce website. Now, think of e-commerce websites like, Flipkart.com, Amazon.com, eBay of the words, right? Now, I will condense or I'll try to condense everything that I've learned so far in this just 30 minutes or 45 minutes video, but it will consist of almost everything that you have to know when it comes to building a highly scalable e-commerce website. So I'll talk about what are the various components, what are some of the non-functional requirements that are needed, what are the capacity requirements, then how the databases should look like. And I will also talk about APIs, some of the APIs that are needed. And then at the last, I'll try to scale the website so that it caters close to 100 million users. And then at the end, I'll also share some of the final thoughts which you can take ahead and then try to explore more from here. So let's dive right into it. But grab a pen and a paper, because I think if you do that, you'll get the most out of this video. So let's start with listing some of the things that I'll cover in this particular video, right? So for example, in this video, I will cover uh, you know the below items. For example, what are the components of a highly scalable website, the functional requirements, then the non-functional requirements, things like it should be fault tolerant, highly consistent, highly scalable, etc. What should be the availability look like, and then some of the capacity requirements in terms of requests per seconds, storage, etc. And then what the database should look like. And then, as I mentioned, some of the food for thought so that you can go ahead and then continue your journey there. Because once you build the website, it's good, but I think after that, you have to consider how will you promote, your changes from one environment to, the higher environments, right? Dev, staging, prod, things like that. Then, if there is a disaster happened in one region, how will you fail over to other region, etc. So these are some of the things that I'll cover. Let's start with the key components of highly scalable e-commerce website, and I'll also call there some of the maybe functional requirements. Like these are definitely needed. The first one, which is very common, is you need a search, and the user should be able to search for a product. And then the other one would be products and inventory, and the other components can be cart, then billing slash checkout, recommendations, review system, and maybe analytics. So this will correspond to users should be able to add to cart whatever they search for. They should be able to write a review, and they should be able to give recommendations for a particular product. So these are some of the key components and functional requirements. Now there can be other components as well, which I'm not talking about here. But an e-commerce website, these are the main components of an e-commerce website. Now moving forward, let's try and talk about some of the non-functional requirements. So this will include things like low latency, which means performance, right? So it should be highly performant, and typically latency should be in milliseconds. So let's say something like less than 300 milliseconds. Then it should be highly consistent. So for example, placing an order, all these things should be consistent, billing, checkout, etc. Then it should be highly available. Now, when I talk about highly available, what I mean is something called uptime or availability. So these are, some of the very important concepts in cloud computing. So let's say I need 99.99% of availability. And what this corresponds to is, if I go to this website, so 99.9% availability will be close to an yearly downtime of 52 minutes or close to 1 hour. So the higher you go, the lower this number will be. So see how a single line can make a big difference, right? So it came from 52 minutes to 5 minutes. If I just try to increase 1 9, and there's another important topic which I'll not cover here, but there's always a compromise that you have to do between performance, scalability, availability, and cost, right? But that's not a topic for this particular video. But as a DevOps engineer, cloud engineer, or cloud architect, you have to keep cost in mind as well. You can't just build something with 100% availability, right? That will cost you like fortunes, which would not be benefiting you, or the revenue you are getting by doing that might not make sense as well, because it's too high to run a 100% uptime service. Now, next one is it should be fault tolerant. Fault tolerancy basically means if a disaster happens, how will your services will tolerate it? And that's where we talk about zonal failures, regional failures, etc. And this is related to high availability, but I just wanted to write that as a requirement. And then from security perspective, you should prevent DDoS, because in today's world, given the number of IoT devices we have, I mean, in every small little thing as well, we have Wi-Fi. So the number of agents have drastically increased. So anyone can just go ahead, hack them, and then try to do a DDoS. I'll not discuss in depth what distributed denial of services, but if you're building a website, you have to think from security perspective as well, and you have to prevent DDoS attacks. Another one is you should follow OWASP top 10. Now, this is again from security perspective, and if I just search for OWASP top 10, you'll see that what that means. So basically, it covers things like your website should be free from broken access control, cryptographic failures, injection, which I think is very important because nowadays a lot of cross-site scripting attacks happen, SQL injections, and all those things. So you have to build, but in terms of the designing it, I'll not cover how you can implement it, but you should keep this in mind whenever you're building something from security perspective. So these are some of the non-functional requirements. Now let's go to some of the capacity estimations. Now this is one area which I like very much because without this you can't just go about and then see like, okay, how many maybe pods you need if you're running in Kubernetes, how many virtual machines you need, or how many any kind of servers that you're running. You can't just run them without knowing the traffic that you'll get on your servers. So in this example, I'll assume close to 400 requests per second. Now let me break down the number. So what I am assuming here is that I have 100 million monthly active users, and any website like Flipkart, Amazon, they have close to this number, or 200 million, but let's start with 100 million monthly active users, and then let's say they search for 10 products per month. So basically that number will be like 1 billion searches per month. Now if you have to support this, what you'll have to do is you'll have to make sure that all these requests are successful. So the number that comes is like 1 billion, and divided by a month is basically 30 days, 24 hours, and then 60 minutes, and then 60 seconds. So if you do all this calculation, the number which comes is close to 380 requests per second, but I've just rounded that figure off, and then I've just kept 400 requests per second. So that's from the request per second side. Now let's talk about storage requirements. Storage wise, let's say this website lists close to 1 million product, and each product has close to 10 MB of files. So this comes out to be close to 10 TB. So if I just write, okay, we need 10 TB of storage space, and 1 million into 10 MB, that is close to 10 TB. So these are some of the capacity estimations that you have to do. Now there are many more estimations that you do, like, okay, the throughput and all those things, but I'll not dive deeper because I think this should be enough. So now moving on, let's talk about the APIs that will be needed. So basically the API will be dependent on these components that we listed. So for example, search for a product, then add to cart API, then we have get recommendations API, and then we have place order API. There will be a cancel order API as well, and the flow will look very similar like place order API, and then get order status and write review. So this is what the APIs will look like. Now let's talk about databases a little bit. Now there will be various databases ranging from user DB, then something like products DB, then there will be order DB, cards DB, recommendations DB, there will be review DB. Now users DB will be SQL database. Products DB, because we will have to have multiple products, each product will have its own description and maybe feature something like that. So this will be a NoSQL database. Then order DB, similarly, it will be NoSQL database. Cards DB also will be NoSQL, and recommendations and review DB also will be NoSQL databases, because apart from user DB, everything else is very dynamic and they might change very frequently. We don't want to get stuck with the schema, so that is why we need to make it very flexible. Now There are various types of NoSQL databases like document DB, key value DB, but let's keep it a little generic here. So I'll consider, okay, let's keep everything as document DB. And what I'll do at the end as well, since I built all these APIs, the components and databases, I will, after the architecture is built, I'll go ahead and then associate them with each of the Google Cloud services. Right now, you can map them to AWS Azure as well. There's a sheet which you can refer to. I'll leave a link of that sheet in the description as well. You can just map everything with Google Cloud, but I'll use Google Cloud for all these components at the later end of the video. Now, that being said, let's go ahead and then construct our website, right? So let's start with something like our compute options. Now, we can run this particular thing in virtual machines. We can run them in something called serverless. And what I mean by that is, something like Cloud Functions or AWS Lambda and Cloud Run or AWS Fargate, right? But as I mentioned, I'll take examples of Google Cloud. And then you have something called containerized, services like Kubernetes, and the implementation is GKE in Google Cloud. And virtual machines are called Compute Engine, right? Google Compute Engines. So these are your options from the compute side. And in terms of databases, we have a lot of databases, right? Like SQL, you can use something like Cloud SQL or RDS. In AWS, we have AlloyDB, which is something similar to Aurora, or we have Spanner, which is our highly distributed horizontal scale database. Then NoSQL wise, we have a couple of options like Firestore, then Bigtable. And then in terms of we need storage, there's something called Google Cloud Storage or S3, which is your object-based storage, where you can keep all your files, videos, etc., static content. So these are the services. Now, once I scale my website, I will talk about queues, the messaging, etc., caches, content delivery networks as well. But let's try and implement the website based on whatever we have discussed so far. So the first thing is definitely we'll have a user. Okay, now the user will send requests to these APIs that we talked about, right? So the first one is search product. So it will be a search service. So search service will then send the request to products database and simultaneously store the results in something called search history database. And then we'll also have something called get recommendations, and get recommendations will fetch out the recommendations from something called a recommendations database. Now you can feed this recommendation database. You can run some jobs, etc., from whatever the user searches, etc., and then send the whatever analysis you do to this recommendations DB. So we'll have something called a analytics engine, which will get the recommendations and it will be feeding into the recommendations DB. Okay, so the user can search for a service and then get recommendations. Now, after searching for the service or after getting the recommendations, what the user can do is they can add something to the cart. So let's build this thing, add to cart, and the request can come from get recommendations or the search service. And once the user selects to add something to the cart, it will go to a cart DB. Okay, so once the user adds something to the cart, they will check out and then buy that item. So we'll call the place order API, and then the place order API will store that order in the order DB. So now we have built search service, get recommendations, add to cart, place order. Let's build get order status and write review. Cancel order will follow the same steps like place order, so I'll not dive deeper into them. But let's talk about check order status or get order status, which will fetch the data from orders DB. And the final one that we have is the write a review, and the review will be stored in something called a products review DB. And based on this review as well, the search service or the recommendation service can show the results to the user. So let's connect these two as well. Nice. Okay, so this is what our design look like. So just to recap, we have built search service, get recommendations, add to cart, place order, get order, and then write review. Now let's try to build everything again, but by using some of the cloud services and then scale this to a planned scale website. So again, let's start with our user or users, and what happens in a real world is that user send request to cloud DNS. So let me quickly find cloud DNS, and then the DNS redirects it to a load balancer. Now we will be using external global application load balancer, which uses something called an Anycast IP. And Anycast IP, basically it's just one single IP, but it's smart enough to work across regions. So basically, if a user is in Europe and if it comes to that Anycast IP, the load balancer is smart enough to route to the services serving from that Europe region. So after cloud load balancing, then comes our compute layer. I'll be using GKE for this particular example. Now let's build all our services like search service and get recommendation service. I'll also have get order service and then write review or product review service. Okay, now this will send the request to our products DB, which will be a NoSQL database, because products, as I mentioned, will have multiple descriptions or separate features, etc. So the schema, we wouldn't want to lock ourselves into the schema of a products database. So I'll use something called Cloud Firestore here, which will serve as our products DB. Now I also have to store search results in a search history database, and that will be a SQL database. So I'll use Cloud SQL for that. Okay, now let's build this get recommendation service database. Now the data will be fed from the products DB and search history database to the recommendations DB. So what we will do is we'll run some kind of analytics, and we can use something like Dataproc or Dataflow to run those jobs. After that, user searches for a product, and then based on that, we can pipe into the recommendations DB, and then the get recommendation service should look at this particular Cloud SQL recommendations database and then able to serve the recommendations to the user. So let's find cloud data flow. Now this can be achieved by another service called batch, cloud batch as well, but I will use Dataflow to run those batch jobs and then update the recommendations DB. Okay, so this is Dataflow, and this will run get recommendations batch jobs. Okay, now this is done. Our search service and get recommendation service are done. Now the user will add the products to the cart, and they will add to the cart via the recommendation service or the search service. So let's build add to cart, and add to cart will store the results in the add to cart database, and that will be a NoSQL database. So in this particular example, I'm using Cloud Firestore for all the NoSQL databases, but you can use Bigtable as well if you have the need for it. Now, once the user adds something to the cart, they will go ahead and then check out or place an order. So let's build the place order service, and the place order service will place the order and then store everything in the orders DB. Again, it's a NoSQL database, and I'll be using Cloud Firestore for that. Now we also have the get order status service, and the get order status service will fetch the orders from orders DB. So it will query the orders DB and then give the status to the user. Now the final one is product review service, and the user will write the review, and it will be stored again in a NoSQL database, and we will use Cloud Firestore for the products review DB as well. So this is what our website will look like. Now let's scale this, right? So for example, we will have all our static content into cloud storage. So all the images and the videos will be served from here. Whenever a product is searched, whenever the recommendation engine serves a product, the images, videos, etc., everything will be stored in cloud storage. Now, one of the non-functional requirement was low latency, and we can do that because every time a request comes to the search service and then it searches for the product from cloud storage, it is served. There's a lot of network hops and latency there. So we have something called Cloud CDN, and we can use that for implementing content delivery network. And you can read about content delivery networks in more detail what it does. But basically, they cache the static content so that you don't have to go to the cloud storage again and again. And that way, like, it is much faster in serving the particular content. And if it is not found, then it goes to cloud storage and then it caches here. Now these are served by something called edge locations. I'll not talk about what are edge locations, etc., but do read about content delivery network if you have to scale your website, because these are key in doing that. Now once this is done, another requirement was to prevent DDoS attacks. So we have a service called Cloud Armor. We can use that. So Cloud Armor it prevents all the DDoS attacks, and you can add other security layers here, like if a request is coming from a certain blacklisted IPs, then Cloud Armor will not allow them, and all those particular things can be achieved by Cloud Armor. Now one thing can happen is if you are trying to add something to the cart, it might fail, etc., right? So because the service might not be available, etc., so we have something called Cloud Pub Sub, and we can add some messaging queues there. So Pub Sub will serve as a queuing layer, and it will queue all the requests so that no request is lost when adding to the cart, etc. And we can place these queues basically everywhere, right, so that we don't lose any particular orders. So let's do that. Now once this is done, what we can do is we can add a caching layer here, so that whenever a user searches for a product, it doesn't have to go to the DB again and again, right? So we can implement something called Redis here, and we have a managed service for that in Google Cloud called Memory Store, and we can use that to cache everything. So we can use the Memory Store here and here. Whenever a get order status service is triggered, we can use the Memory Store over here as well, so that it will cache all the recent feedback, etc. So this is how I will design the highly scalable website. Now one thing you can also do is you can send a notification whenever a order is placed to the user, right? And you can do that again by implementing PubSub. So yes, you can do this as well. Now this is what a highly scalable website will look like. Now as I mentioned, so this is a very high level overview of everything. Now there are tens of things. Again, you can dive deeper. So for example, this is running in a region, right? So what you can do to implement a disaster recovery strategy, so you can replicate everything here into another region. So for example, suppose this is in US West 1, and what you can do is you can fully replicate this in maybe Europe as well, so that you can serve your users there. And as you mentioned, Google Cloud Load Balancing uses something called an Anycast IP. So if the user is in Europe, the request will come to this particular GKE cluster, right? So for example, this user is coming from Europe region, then the load balancer will be smart enough to redirect the request to this particular region. And similarly, if this is coming from US region, then it will go to this particular GKE cluster running in US West 1. Now if this goes down, then the load balancer is again smart enough to figure out that this entire region is down, some of the services are not working, then as a fallback it will redirect here. So do try out all these things. I am not diving deeper into all those things, but feature of highly scalable website is that fault tolerancy, and you have to make sure that it is globally available and all those things. And if a region goes down, the service shouldn't go down, right? And that's how you will be able to achieve that 99.99% availability. So one thing to keep in mind is, if you see all these are managed services, you have to have proper configuration in place in order to make sure that they scale. For example, in Cloud Firestore, you have those SLAs where it says that it is available 99.99% if you spin up a regional Firestore instance, and 5 nines, which is 99.999 if you use multi-regional Firestore. So all those settings you will find for Cloud SQL as well, where you can have read replicas, and then you will have to configure if you want to have another Cloud SQL in another region, and then how you replicate the data, etc. Then you can do the same for Memory Store. Your GKE clusters, you should run them regional, right? You don't want to run them zonal, because if one zone goes down, then your entire application goes down, right? So you have to make sure that you run it in a regional setup, and then you can also expand it to multi-region that I talked about some minutes ago as well. Same goes for cloud storage, where you can choose between regional cloud storage or multi-regional cloud storage. But I just wanted to make sure that you understand that I'm using managed services here, so they take the overhead of those high availabilities and making sure that it scales based on the number of transactions, and as the traffic increases based on the increased number of users as well. Now once this is done, there will be multiple environments like dev, QA, staging, and prod. So you will replicate entire thing 4 times. Then you will have to have a solid CI/CD pipeline to first deploy it in dev, then QA, then staging, and then to prod. And you will have to have proper integration, unit test, and load testing in place, so that you can promote something in the prod environment. Now another thing is, if you are talking about DR, you will have to have your recovery point objectives, recovery time objectives in place, because you don't want to lose any data, and you don't want downtime more than 52 minutes in the entire year. So you'll have to define all those things, the SLI, SLO, SLAs, service level objectives, and the agreements, etc. if you are designing all this. Now I'm giving this as my final thought, so that you can dive deeper into all these concepts that I'm talking about. So another thing you can do is chaos engineering as well. You can fail some of the service, see how it is behaving, whether this PubSub is storing the messages or not, if the add to cart is failed, and if the add to cart comes back up again, and how the processing happens, all those things, right? You have to do that in the production environment. So perform the load testing, perform the chaos testing, define your RPOs, RTOs, the disaster strategy, etc. And don't just define it, you test your disaster recovery strategy as well. So yeah, that's all I had from this particular video. So I hope you like this video, and if you like this video, then you'll like these two videos as well, where I talk about the 7 real world projects that you can do and the top Kubernetes tools that you can learn in this rapidly evolving DevOps space. So see you on the other side. Thank you so much.